Hello everybody,
My name is Maulana Hafiz Reza and my friend name is.
Daniel Junianto,
We are from
Universitas Riau.
uh, here. We will explain about the transmission media, and we are sorry if our grammar is bad.
Check it out. Okay, I will to explain to you about transmission media. Transmission media is a medium that connects the sender and receiver of information or data. Because of the long distance, then the data is first converted into a code or signal, and the signal will be manipulated in various ways to be converted back into data. Transmission media is used on several electronic devices to connect between senders and receivers in order to exchange data. Some electronics devices, such as telephones, computers, televisions, and radios, require transmission media to receive data. As with telephones, the transmission media used to connect to phones is wired. Several factors relate to transmission and signal media as determinants of the data rate and distance are as follows. First, bandwidth. The bigger, the more the data can be sent. Second, transmission impartment. For integrated media, twice pair transmission cable generally experience more damage than coaxial cable, and coaxial data contain more damage than fiber optic. Third, interference. Interference from thermal overlapping signal or frequency bands can cause distortion or can damage a signal. And last, a number of recipients or receivers. And integrated media can be used to bring a pioneering to point relationship or a relationship the use together. Okay, usability of transmission media. Transmission several media is used on electronic devices to connect between sender and receivers in order to exchange data. Some electronic devices, uh, such as telephones, computers, televisions, and radio, require transmission media to receive data. As with telephones, the transmission media used to connect to phones is wide. Every electronic equipment has seen its different transmission media of data transmission. And transmission medium generally, there are two categories of transmission media items, namely A. Guided media or media guided, and B. Unguided media or media not guided. Okay, one guided media. Uh, a coaxial cable. This is the physical of coaxial cable. What is coaxial cable? Coaxial cable is a transmission line that consists of the tube of the electronic conducting materials surrounding a central connector held in place by insulator, and that is used to transmit telegraph, telephone, television, and internet signals. Various kinds of coaxial cable. A. Thick coaxial. Bino with 10 base 5 name, used for backbone cables at the plant at network between buildings. And B. Thin coaxial. Bino as a 10 base 2 or chepten or RG 58 or TNET, used for networking between workstations, can be for the implementation of bus entering telepages of as handled physically. This is the structure of coaxial cable. The one outside sheet of jacket. It is insulate and protect shielding and center conductor. Extrude PVC is typical. The conducting sheet. The shielding is one of two conductors in coaxial cable. Bed of brain plus foil is typical. The 3 insulating layer. This is insulating material isolator celled from center conductor. This also gives the cable its impedance property. And the last center conductors. This is the main signal path. Can be solid or stranded wire. Okay. Next, the advantage of coaxial cable. Okay, next, the advantages of coaxial cable are the first, having a high bandwidth, so it can be used for broadband communication or multiple channel. The second, almost unaffected noise. The last, the price is relatively cheap. And the weakness of the coaxial cable are the first, it uses a jacket, and the second, the coaxial difficult to install in some kind of space, and last, if the cable trouble, then the data communication is interrupted. The two twice pair. This is the physical of twice pair cable. What is twice pair? A twisted pair cable is the type of cable made by putting two separate insulate wires together in the twice pattern and running them parallel to each other. This type of cable is widely used in different kinds of data and voice infrastructures. Okay, this is the two types of the twice cable. This is the shielded twice pair or STP and unshielded twice pair and or UTP. Two different types of twice pair cable. This is unshielded twice pair or UTP and shielded twice pair or STP are used in the different kinds of installation. UTP is common in Ethernet installation, while STP is used in various kinds of network to prevent crosstalk and automatic interference. STP cable can also help to provide grounding. Okay, this is the table of different UTP and STP. For basic, UTP or unshielded twice pair is the cable with wires that are twice together. STP or shielded twice pair is a twice pair cable enclosed in foil or mesh shield. For noise and crosstalk generation, UTP high comparatively and STP less susceptible to noise and crosstalk. For grounding cable, UTP not required. STP necessarily required. For ease of handling, UTP easily installed as cable are smaller, lighter, and flexible. STP installation of cable is difficult comparatively. For cost, UTP cheaper and does not require much maintenance. STP is moderately expensive. For data rates, STP slow comparatively, and STP provides high data. Okay, the three fiber optic. This is the physical of fiber optic cable. An optical fiber cable is a type of cable that has a number of optical fiber bundled together, which are normally covered in the individual protective plastic covers. Optical cables are used to transfer digital data signals in the form of the light up to distance of hundreds of miles with higher throughput rates than those activable via electronic communication cable. All optical fiber use a core of hair-like transparency comfort with less refractive indexed cladding to avoid like leakage to the surroundings. Due to the extreme sensitivity of the optical fiber, it is normally covered with a high strength, lightweight protective band like Kevlar. Okay, this is the structure of fiber optic, uh, and this outer jacket. Outer jacket and string member. This is the layer is very important because it is the main protector of the fiber optic cable. String member layer and outer jacket is the outermost part of optical fiber that protects the cable core from various physical disorders directly. And the coating or buffer section is a coat of optical fibers that is different from cladding and cores. This coating is made of elastic plastic material. Uh, the coating serves as the protective layer of all the physical disturbance that may occur, such as curvature in cable, handling in the cable. Next, the cladding. Cladding is protective part that directly cover the optical fiber. Usually, the size of the cladding is 5 micrometers to 250 micrometers in diameter. Cladding is made of silicone, and the composition of the material is different from the core. In addition to protect the core, the cladding also function as the light wave guide that reflect all light through of the core. And the last, the core. The core part of optical fiber is made of glass material with a very small diameter. Diameter is about 2 micrometers to 50 micrometers. Large diameter optical fiber will make a better and more stable performance. Okay, types of fiber optic cables. The one, single mode optical fiber. Single mode fiber optic cable, which is a network cable that has only one, can only distribute the light through one time. This type of optical fiber uses a diameter of about 9 micrometer, which is used to transmit light wave from long wave of 1300 to 1550 nanometers. And the two, multimode optical fiber. Multimode fiber optic cable is a cable that can transmit a lot of light at the same time because it has the large size that has the diameter of about 625 micrometers. This cable is used for commercial purposes, which are generally accessed by many people. This optical fiber uses infrared light that has a length of 850 to 1300 nanometers. Okay, this is the different table of single mode and multi-mode. Uh, you can see in this table uh, for different of large core diameter, type of light, lots of light, type of light emission, distance of light, bandwidth, and cost for single mode and multi-mode. Okay. Okay. Is the advantages of optical fiber are as follows. The one, fiber optic cables have a much greater bandwidth and much thinner and lighter than metal cables. The two, an optical fiber offers low power loss, which allows for longer transmission distances. 3. Fiber optic cables are immune to electromagnetic interference. 4. In comparison to copper, a fiber optic cable has nearly 4.5 times as much capacity as the wire cable has, and a cross-sectional area that is 30 times less. 5. An optical fiber has greater tensile strength than copper or steel fiber of the same diameter. And last, the raw materials for glass are plentiful unlike copper. This means glass can be made more cheaply than copper. The disadvantage of the optical fiber is as follows. The one, the optical fibers are difficult to splice and there are loss the light in the fiber due to sintering that has limited physical of cable. If you bend them too much, they will break. 2. The optical fiber are more expensive to install, and they have to be installed by the specialists. They are not as robust as the wires. Special test equipment is often required to the optical fiber. 3. The fiber optic cable is a small and compact cable, and it is highly susceptible to becoming cut or damaged during installation of the construction activities. The fiber optic cable can provide tremendous data transmission compatibilities. 4. The transmission on the optical fiber requires repeating at the distance interval. The fiber can be broken or have transmission losses when wrapped around curves of the only a few centimeters radius.
Unguided media. Unguided medium transport electromagnetic wave without using a physical conductor. This type of communication is often referred to as wireless communication. Signals are normally broadcast through free space and thus are available to anyone who has a device capable of receiving them. The below figure shows the part of the electromagnetic spectrum ranging from 3 kHz to 900 THz used for wireless communication. Unguided signal can travel from the source to the destination in several ways. First, ground propagation, second, sky propagation, and third, line of sight propagation, as shown in the below figure. Ground propagation, in this, radio wave travel through the lowest portion of the atmosphere, hugging the Earth. These low-frequency signals emanate in all directions from the transmitting antenna and follow the curvature of the planet. Sky propagation. In this, Higher frequency radio wave radiate upward into the ionosphere, where they are reflected back to Earth. This type of transmission allows for greater distance with lower output power. Line of sight propagation. In this type, very high frequency signals are transmitted in straight line directly from antenna to antenna. We can divide wireless transmission into three broad groups. First, radio wave, second, microwave, and third, infrared wave. First, radio wave. Electromagnetic wave ranging in frequency between 3 kHz and 1 GHz are normally called radio wave. Radio wave are omnidirectional. When an antenna transmits radio wave, they are propagated in all directions. This means that the sending and receiving antenna do not have to be aligned. A sending antenna send wave that can be received by any receiving antenna. The omnidirectional properties has disadvantage too. The radio wave transmitted by one antenna are susceptible to interference by another antenna that might send signal showing the same frequency or band. Radio wave, particularly with those of low and medium frequency, can penetrate walls. This characteristic can be both an advantage and disadvantage. It is an advantage because an EM radio can receive signals inside a building. It is an disadvantage because we cannot isolate a communication to just inside or outside a building. Omnidirectional antenna for radio wave. Radio wave use omnidirectional antennas that send out signal in all directions. Application of radio wave. The omnidirectional characteristic of radio wave make them useful for multicasting, in which there is one sender but many receiver. EM and FM radio, television, maritime radio, cordless phones, and paging are examples of multicasting. Second, microwave. Electromagnetic wave having frequency between 1 and 300 GHz are called microwave. Microwave are unidirectional. When an antenna transmits microwave, they can be narrowly focused. This means that the sending and receiving antennas need to be aligned. The unidirectional property has an obvious advantage. A pair of antennas can be aligned without interfering with another pair of aligned antennas. The following describe some characteristics of microwave propagation. First, microwave propagation is line of sight. Since the tower with the mounted antennas need to be in direct sight of each other. Towers that are far apart need to be very tall. Second, very high frequency microwave cannot penetrate walls. This characteristic can be a disadvantage if receivers are inside the building. Third, the microwave band is relatively wide, almost 299 GHz. Therefore, wider subbands can be assigned and a high data rate is possible. And last, use of certain portion of the band require permission from authorities. Unidirectional antenna for microwave. Microwave need unidirectional antennas that send out signal in one direction. Two types of antennas are used for microwave communication. First, parabolic dish, and second, horn. A parabolic antenna works as a funnel, catching a wide range of waves and directing them to a common point. In this way, more of the signal is recovered than would be possible with a single point receiver. A horn antenna looks like a gigantic scoop. Outgoing transmission are broadcast up a stem and deflected outward in a series of narrow parallel beams by the curved head. Received transmission are collected by the scooped shape of the horn in a manner similar to the parabolic dish and are deflected down into the stem. Application of microwave. Microwave, due to their unidirectional properties, are very useful when unicast one-to-one communication is needed between the sender and the receiver. They are used in cellular phones, satellite network, and wireless LANs. There are two types of microwave transmission: A. Terrestrial microwave and B. Satellite microwave. Advantage and disadvantage of microwave transmission. Advantage of microwave transmission. First, use it for long distance telephone communication. Second, carries 1,000 of voice channel at the same time. Disadvantage of microwave transmission. It is very costly. A. Terrestrial microwave. For increasing the distance served by terrestrial microwave, repeaters can be installed with each antenna. The signal received by an antenna can be converted into transmittable form and relayed to the next antenna as shown in below figure. It is an example of telephone system all over the world. There are two types of antennas used for terrestrial microwave communication: parabolic dish antenna and horn antenna. Parabolic dish antenna. In this, every line parallel to the line of symmetry reflects off the curve at angles in a way that they intersect at a common point called focus. In this antenna is based on geometry of parabola. Horn antenna. It is like gigantic scoop. The outgoing transmission are broadcast upstem and deflected outward in a series of narrow parallel beams by curved head. B. Satellite microwave. This is a microwave relay station which is placed in outer space. The satellites are launched either by rockets or space shuttles carry them. These are positioned 36,000 km above the equator with an orbit speed that exactly matches the rotation speed of the Earth. As the satellite is positioned in an geosynchronous orbit, it is stationary relative to Earth and always stays over the same point on the ground. This is usually done to allow ground station to aim antenna at a fixed point in the sky. Features of satellite microwave. First, bandwidth capacity depends on the frequency used. Second, satellite microwave deployment for orbiting satellite is difficult. Advantage and disadvantage of satellite microwave. Advantage of satellite microwave. First, transmitting station can receive back its own transmission and check whether the satellite has transmitted information correctly. Second, a single microwave relay station which is visible from any point. Disadvantage of satellite microwave. Satellite manufacturing cost is very high. Cost of launching satellite is very expensive. Transmission highly depends on weather condition. It can go down in a bad weather. Third, infrared wave. Infrared wave frequency from 300 GHz to 400 THz can be used for short-range communication. Infrared wave having high frequency cannot penetrate walls. Disadvantageous characteristic prevent interference between one system and another. A short-range communication system is on room cannot be affected by another system in the next room. When we use infrared remote control, we do not interfere with the use of the remote by our neighbor. However, these same characteristics make infrared signals useless for long-range communication. In addition, we cannot use infrared wave outside a building because the sunlight contains infrared wave that can interfere with the communication. Application of infrared wave. The infrared band, almost 400 terahertz, has an excellent potential for data transmission. Such a wide bandwidth can be used to transmit digital data with a very high data rate. The Infrared Data Association, or IRDA, an association for sponsoring the use of infrared wave, has established standards for using the signal for communication between devices such as keyboard, mouse, PCs, and printers. Infrared signal can be used for short-range communication in a closed area using line of sight propagation. And that's it.